Classification, Unit 6, Video 3. So imagine a store, any store. How do you know where to find the milk or the cereal? Are they on the same aisle? How is this particular store organized? Are all stores similar? Are all stores the same? What about if you wanted to find a CD or a movie? How would you know where to find it? Imagine your computer or your iPod, all of your songs and files in a single folder, or do you have them grouped in some way? Do you have favorite online stores? Were they organized where you go to find things? We call all of the above and even everything on the screen classification. So we have the classification of our vehicles, motorcycles, passenger cars, what you would go to the DMV to get a special license for. We have the Federation fleet, where we would classify these different ships based upon their shape and their capabilities. We even classify daffodils based upon their cup size, the size of the trumpet that is on the daffodil, or the number of petals that they have. So take a look at this picture. Are all the people in the picture describing the same thing? I would think so. But because they were using different languages, it's hard to know if they really are talking about the same thing. So in science, we use a common language to name all of our organisms. So in science, we use scientific language, and we would call this skunk Mephitis mephitis. This is Latin, and that is the common language for science. So classification is the arrangement of organisms into orderly groups based on their similarities. We also call it taxonomy. So it will accurately and uniformly name all of the organisms that we know of, and prevents misnomers such as starfish or jellyfish that aren't really fish. Did you know that? A starfish isn't really a fish, neither is a jellyfish. So their scientific names would help us get over that misnomer, that misinformation. We use the same language, Latin and sometimes Greek, for all the names. Carolus Linnaeus was the man who we credit with most of our knowledge about taxonomy, and he was the first one to really give us a concrete classification system. He was an 18th century taxonomist, and he classified organisms based on their structure. He developed the naming system that we still use today, that is the binomial nomenclature that we use. And he published all of this in the Systema Naturae, which is his book on how we classify it. He also redid his name to fit within his binomial nomenclature scheme. He's called the father of taxonomy, and he developed the modern system of naming known as binomial nomenclature. So binomial, bi meaning two, nomial name, and nomenclature again with the naming. We have a two-word name, genus and species, and we always italicize it, and the genus name is always capitalized. So the standardized naming in binomial nomenclature is the genus and species. It's italicized in print, and you capitalize the genus but not the species, and you underline it when you're writing. So to properly put this one out here, the robin, which is the American robin, is Turdus migratorus. Binomial nomenclature. If you take a look at these three pictures, which two are more closely related? The giant panda, the polar bear, or the grizzly bear? I would hope that you would say that the polar bear and the grizzly bear are more closely related because of the Ursus as their genus name. The giant panda is not even closely related to these guys. It's a far distant cousin. He's not even in the same genus. So our rules for naming. The International Code for Binomial Nomenclature contains the rules for naming organisms. All names must be approved by the International Naming Congresses, International Zoological Congress, and this prevents duplicated names. Say you're doing a study in the Amazon and you find some insects, you want to make sure that you name it properly. So classification groups, we have a taxon, or taxa, is a category into which related organisms are placed. There's a hierarchy of groups, taxa from broadest to most specific. And they are domain, kingdom, phylum, class, order, family, genus, species. So, if you would, on a piece of paper or in your notes somewhere, fill in the blanks: kingdom blank, class order blank, genus blank. You can even go back and look. And which two groups are used for an organism's scientific name? And which of the following pairs are most closely related? The Acer rubrum and Acer saccharum, or the Acer rubrum and the Chenopodium rubrum? The system we use for naming is called blank nomenclature, and the science of classification is called blank. So for number one, it is kingdom, phylum, class, order, family, genus, species. The two groups that are used for an organism's scientific name are the genus and species. The pair that is the most closely related are the Acer rubrum and the Acer saccharum. Those are both maples. The system we use for naming is called binomial nomenclature, and the science of classification is called taxonomy. Taxonomic groups: domain, kingdom, phylum, class, order, family, genus, species. Domain is the most broad, and it includes everything. We have three domains. We have Prokarya, Eukarya, and Archaea. Species is the most specific. This is where we're talking about sapiens, domesticus, things of that nature, the most specific names. So here we have, in a kingdom, we would have all of the animals. In the phylum, we would have all the things that would have backbones. In the class, we would have all the mammals. In the order, all the carnivorans. In the Ursidae, all the bears. In Ursus, the closely related bears. And then the species would be the specific bear. One way to remember all of this is through mnemonic devices. Dumb King Philip came over for gooseberry soup. Or Dumb King Philip called our family green stot. Or Dumb King Philip came over for green spaghetti. Whatever you choose, just know that these are the orders that this is going to be in. You're going to have domain, kingdom, phylum, class, order, family, genus, species. So the classification of humans. Well, we are in these following domains: kingdoms, phylums, class, order, family, genus, and species. And the characteristics of those things are listed to the right. So in the eukaryon domain, we have cells that have nucleuses. In kingdom Animalia, multicellular, motile, and ingestion of food. Chordates have a dorsal supporting rod, a backbone, and a nerve cord. Mammals have hair and mammary glands. Primates are adapted to climb trees. Hominidae is adapted to walk erect. Homo have a large brain and we use tools. And sapiens is body proportions of modern humans. To specify an organism, you have to use the full binomial name, like Homo sapiens. A cladogram. One of the ways that we in the modern classification systems to show how organisms are related based on their shared derived characteristics, such as feather, hair, or scales, is called a cladogram. And it shows where along the evolutionary timeline certain characteristics showed up and were carried on through the rest of the organisms. So in this particular cladogram, you start off with the lancelets, which are very simple, and then as we move forward, we integrate them. They have a vertebral column. Then they have jawbones. And everything after that will have those characteristics. Four-legged locomotion. As we go on, everything else has four-legged locomotion. Amniotic eggs. As we go on, everything else has amniotic eggs. Hair. As everything goes on, we have hair. So this is just showing how things are going forward. And this shows how things would split off as we move forward. Dichotomous keys are another way of classifying and looking at animals. So they are used to identify organisms. Characteristics are given in pairs, And you read both characteristics and either go to another set of characteristics or identify the organism, and that makes sense in a minute. So here's an example of a dichotomous key. Let's just choose an organism. Say we choose the anemone down here. I already know this is an anemone, but let's go through all the process. Tentacles present or tentacles absent? Well, the tentacles are absent. It doesn't have tentacles. Then we go to 3. Tentacles hang down or tentacles upright? Well, anemone. And that's how you do a dichotomous key. I hope this was helpful. If you have any questions, let me know. Just make sure you fill out your notes, and I will talk to you soon. Bye.